Okay, so the purpose of this video is to demonstrate one approach that someone might take to try and locate an object that was identified a couple of nights ago. So I've been provided these images. There are 42 images, each a minute and a half in duration. So the first thing we want to do is paste in the observations that we have so far on this object. So I'm going to go to Tools, Existing Observations, and I'm going to go ahead and paste the observations in here, and then attach ephemeris to the dataset. So this will invoke the find orb software, which will then compute ephemeris information, and that we can then return to the Tycho software. So this gives us confidence that the object is in the field of view, so that's a good thing to start off with. And the approach that was originally taken was to go to the image viewer and then create a stack based upon that ephemeris information. So sometimes this will work just fine. It actually works a lot better if it's a near-Earth object. If it's a main belt asteroid, the problem is that a lot of main belt asteroids share the same motion, and so if you're in a field that has a lot of main belt asteroids in it, then you might be it might be difficult to determine exactly which one it ought to be. But here's an asteroid for sure. It stands out compared with the stars that have streaked motion. This is certainly an asteroid, but I would say that that's certainly a lot brighter than what it should be. This was indicated as being magnitude 20 from that first night, and this is a lot brighter than that. But nevertheless, if we were curious to see if this was a match, then we could create a track from that. And this will give us an animation. As you can see, it certainly is an asteroid. And the issue is that, again, it's probably not the match, but we'll go ahead and try. So if I then try to link that up with the first night of observations, find orb tells me there's a very high residual here, 6.2 and 6.2 and so forth. So this is definitely not a match. It's magnitude 18 versus magnitude 20. So I'm inclined to say that this is not the object of interest. So what can we do? Well, another approach you could take, sure, you could try to find other potential candidates here, use this other layer to look at things potentially. But what I like to try to do actually is run the synthetic tracker. So we'll start with that. So these are the steps to invoke it. So auto threshold is for the star mask, and then 50% default, that's good. And finally, we're going to say this is a known object, so use dataset ephemeris. So that will put limits on speed and position angle. And it's very quick, of course, because there's limits. And this comes back with a lot of results, but that's okay. What we want to do, and if we wanted to, we could load MPC orbital database, that's fine. But really what we want to do to help narrow our search is to find object by ephemeris. In other words, it's going to take these list of results and sort them by proximity to the object that we're looking for. So it says track number 7 is the closest to where we expect the object to be. Now if I do verify track on that, well, it looks like the same object that we just saw a moment ago. So I'm not going to bother with that one. I'm going to the next result, which is track number 25 here. And this looks to be a very faint object, very faint detection. Now what's nice about this upcoming version of Tycho is that we have better contrast controls. So I can adjust the contrast, and as you see, now we start to see an object appear. It's more apparent that this is in fact an asteroid. So the unfortunate thing is that it does go in front of a star. So that will tend to impair the photometry measurement and potentially the position measurement. But Tycho actually does a very good job at measuring the position of an object even when it falls in front of a stationary object. So let's go ahead and try this object and to see if it is a match. So I'm going to click Add Observations, and let's see what we have here. And I should give it the same designation that we had on that first night to make things easier. So paste in the first night, and here we have find orb telling us that this is in fact a good link because the residuals now are all very low. If I wanted to, I could turn that option on and it's still the same scenario. So we have definitely a very good match here. So I'm inclined to say that this is, in fact, the object from the first night. So here was the first substack, the second, and the third. So we're expecting it to be about magnitude 20. Of course, because we have so much star interference, what happens here is these tend to elevate the background level, so it will appear to be a very faint object compared to the background, so that will in turn tend to make it think it's a fainter object. So we have mag 20.7 here, and these other two substacks, it thinks it's only magnitude 19 essentially, but that's because it is now in front of a star that elevates the signal of the object. So you're not going to get particularly good photometry information in this circumstance, but nevertheless, we were still able to get good measurement, good position information. So that's what really matters for astrometry anyway. So if you wanted to, you could then follow it up on another night and so forth, but there's very good confidence here that this is the same object as night 1. So hopefully that gives some insight on another approach to locating an object. It's a very faint object, so that makes things tricky, but nevertheless, it looks like this is, in fact, a feasible follow-up. So thanks for watching, and see you next time.